Right, so we're at question number 10, and question number 10 says, question number 10, AI says, calculate the matrix product. All right, 5, 4 minus 3 minus 2, 2, 1, 4, 0, 3, 6. So whenever we're multiplying two matrices, we multiply the rows of the first matrix by the columns in the second matrix. So let's start. 1, 1, 2, 1, 2. I won't do that again. So I'm going to multiply the rows of the first matrix by the column in the second matrix. Every time you multiply a row by a column, you get an element in the answer. So if I multiply the top row by the left column, I'm going to get the top left element in the answer. So let's go. First element in the row times the first element in the column. 5 times 2 is 10. And the second element in the row times the second element of the column. 4 times 0 is 0. So that's the first element, the top left element. All right, so let's erase these numbers. The top row by the middle column, 5 times 1 is 5, and 4 times 3 is 12. Top row, column to the right, 5 times minus 4 is minus 20, and 4 times 6 is 24. So I just multiply the top row by all the columns. I'm going to multiply the bottom row by all the columns. This is minus 3 times 2 is minus 6. Minus 2 times 0 is 0. Minus 3 times 1 is minus 3. Minus 2 times 3 is minus 6. Minus 3 times minus 4 is positive 12. Minus 2 times 6 is minus 12. And so our final answer is 10 minus 6, 17 minus 9, 4, 0. So this is the matrix product. The next thing we're asked to do is to state why the two matrices in AI are compatible for multiplication. All right, well, two matrices are compatible for multiplication because the number of columns in the first matrix and the number of columns here is 2 is equal to the number of rows in the second matrix. Which is also 2. So two matrices are compatible for multiplication when the number of columns in the first matrix is equal to the number of rows in the second matrix. Next, we're asked to determine the matrix inverse. So this is the matrix is 5, 4, minus 3, minus 2. Let's call it A. Let's call it matrix A. Might be easier to just do that. So I'm calling it matrix A. So A inverse is equal to 1 over the determinant of A times adjoint A. Now, the determinant of A is 5 times minus 2, which is minus 10, minus 4 times minus 3, which is minus 12. So this is minus 10 plus 12, which is 2. So it means, therefore, that A inverse is 1 over 2 times adjoint A. Now for adjoint A, the leading diagonal elements, 5 and minus 2, switch around. So this is minus 2, 5. The other two elements stay where they are, but their signs change. This to minus 4, and this to positive 3. And so A inverse. All right, I'm going to multiply all the elements by a half. So this is minus 1, minus 2, 3 over 2, and 5 over 2. This is my matrix inverse. Multiplying by a half is the same as saying divide by 2. All right, so the very last question in the exam, or the very last part of the last question. This says the diagram below shows triangle OAB, in which OA is the vector OA is R, the vector OB is common S. In addition, E is the midpoint of CD, OC is 3/4 of OA, and AD is 2/3 of AB. We're to write in terms of R and S, the simplest form, in the simplest form, an expression for CD. Well, let's get CD. Well, first of all, CD using the triangle law of vectors, vector CD is equal to CA plus AD. That's a triangle law of vectors. Now, CA is equal to 1/3 of OA, and AD is equal to, the vector AD is equal to 2/3 of the vector AB. All right, so I don't know what the vector AB is. So as it relates to solving this question, I'm not going to reach anywhere until I find the vector AB. It's not difficult to find. AB is the vector AO plus the vector OB. Now, if the vector OA is R, the vector AO would be minus R. So this is minus R plus OB, which is S. So just put in the positive first. We have S minus R. So coming back to CD, it's 1/3 of OA, which is 1/3 of R, plus 2/3 of AB, which is S minus R. All right. So we're to write the answer in its simplest form. So let's, well, the LCM is 3. So this would be equal to 3. Well, I think I made a mistake somewhere. Let's go back and track it. It's not OC is OA is 3/4. So this is not a third. It is not a third, it's a quarter. All right. I felt it. I felt the mistake. So this is a quarter. This is a quarter R. The LCM is 12. 4 into 12 goes 3 times. 3 times R is 3R. 2 into 12 goes 4 times. 4 times 2 is 8. S minus R. Separate this. All right, so this is 3R plus 8S minus 8R. And this is over 12. So my final answer, the vector CD, is equal to 112. 8S minus 8 minus 8 plus 3 is minus 5R. All right, so dividing by the 12 by 12 is the same as multiplying by 1 over 12. Let's find OE. Well, OE, the vector OE is OC plus CE, is OC plus CE, and this is triangle law of vectors. All right, so let's go for OC. OC is 3/4 of OA. This is 3/4 of OA plus CD, CE, which is a half of CD. So this is a half of CD. So this is 3/4 of R. Slight mistake. 3/4 of R plus a half of 1/12 of 8S minus 5R. Don't get nervous. The LCM is 24. 4 into 24 is 6. 6 times 3 is 18. This is 18R. 24 into 24 is 1. 1 times 8S minus 5R. It is 8S minus 5R. So the vector OE is 1 over 24. All right, let's write an additional line. So this is 18R minus 5R plus 8S over 24. This is 1 over 24. 13R plus 8S. All right, good. Let's see what the next page brings. D. So there's a D part of the question. I thought we were at the final part, but we're wrong. It says the points O, Q, and R have coordinates 0, 0, the origin, 5, 5, 2, that is Q, and minus 1, 4, that is R, respectively. We are to write as a column vector the vector OR. Well, OR is a position vector, which is a vector that is tied to the origin. Now, the position vector and the coordinates of this and the coordinate of the same value. So R is the point minus 1, 4. So R is the point minus 1, 4. So the position vector OR is minus 1, 4. So position vector and coordinates, and the coordinates have the same value. So this is -1, 4. All right. And let us see what else we need. And we need the determine the magnitude of the vector QR. So sorry, wrong direction. QR, let's identify QR as QR is here. So first, let's find QR using the triangle law of vectors. Find QR before we can determine the magnitude. All right, so the vector QR is equal to the vector QO plus the vector OR. That's a triangle law of vectors. All right, QO, this is 5, 2, sorry, 5, 2. So it's, okay, so OQ is 5, 2. OQ is 5, 2, so this is minus 5, 2. So if OQ is 5, 2, QO is minus 5, 2, plus OR, which is -1, 4. So this is minus 5 minus 1 minus 2 plus 4. So here, positive times a negative is a negative. So this would be -6, positive 2. Now, the magnitude of QR would be equal to the square root of -6 squared plus 2 squared. This is the square root of 36 plus 4. It's the square root of 40. So the answer here is 6.32 units. All right, let's look if they put any restriction on it. No. So the magnitude of the vector QR is 6.32 units. And that would be the end of the exam.